Geometry, Chapter 6, Lesson 7, Proofs Using Coordinate Geometry. And we'll take a look at that in a subsequent video, proving some different lengths or parallel lines using slope and the coordinate geometry, placing figures in the coordinate plane we talked about in a previous video. In the first part of this lesson, though, we want to look at a characteristics of a trapezoid that we have not covered yet. So we'll do that first. So we'll look at the trapezoid midsegment. And you remember when we talked about triangles, we had a segment that if we connected the two midpoints of two sides, that this was called the midsegment of the triangle. And that created two characteristics. This segment would be parallel to this third side, and this segment was 1/2 the length of this third side. And we're going to do much the same thing with the trapezoid, where we're going to connect the two non-parallel sides, the midpoints of those two sides, and if we do, that is the midsegment of the trapezoid. So a trapezoid has a midsegment much like the triangle did, and again is connecting the two midpoints of the non-parallel sides. So again, the if of this is we need to be sure that we're connecting the midpoints of the sides. Now, if that's the case, it creates two characteristics, much like the triangle midsegment did. And the first one is exactly the same as the triangle midsegment in that this side will be parallel to the bases. So this will be parallel to RA, and this midsegment will also be parallel to TP. In addition to that, the second characteristic is the length of this is 1/2 the two bases added together. So unlike the triangle, where it only had one side that it was 1/2 the length of, the trapezoid midsegment is 1/2 the length of the two parallel sides added together. So we should be able to then write an equation which allows us to determine the lengths of different sides if we are given enough information. So the midsegment is 1/2 the sum of the parallel sides. So using that, we should be able to solve some lengths of sides using that equation. Let's use one quick example here where we are given the length of RA is 18, the length of TP is 24. What would be the length of this midsegment? We know it's a midsegment because it connects the two midpoints of the non-parallel sides. So then again, my algebraic expression is that MN is 1/2 the length or the sum of the parallel sides. So MN is 1/2 the two parallel sides added together. I write the geometric equation. I then substitute in the lengths that I'm given, 24 and 18. 24 and 18 is 42. I take 1/2 of 42 is 21, so the length of the midsegment is 21. In this example, it's the same theorem that we want to use, except in this case we're given the length of the midsegment and we want to determine the length of the missing parallel side. We begin with the exact same theorem that the midsegment is 1/2 the sum of the parallel sides. So we write that geometrically. We then substitute in the values that we're given. So 18 is 1/2 of RA, which I don't know, plus TP, which I do know is 24. I then can multiply both sides by 2, and this is careful. By multiplying both sides of 2, I can then take 1/2 of 2, or multiply 1/2 times 2, which leaves me just 1. And then 1 times RA minus 24 is RA plus 24. I think I said minus, so RA plus 24. And then 2 times the 18 is 36. I then subtract 24 from both sides, so I determine the length of RA to be 12. So the midsegment of a trapezoid is a segment that connects the two midpoints of that segment, and this midsegment is parallel to these bases, and it's also 1/2 the sum of the two bases, or the sum of the two parallel sides. So I will always start with the geometric expression, and then I just substitute in two of the values that they give me, and then I can solve for the third.